Okay. Now, like I said, the proofs, as we'll just go through here and see if you can kind of fill in what you think and see as we progress today, tomorrow, you're doing a little bit better. So with number one, let's start here. Now, these are just properties. So they just want to make sure you're familiar with that. If I ask you about number one, if DE is equal to GH, then of course GH is congruent to DE. Does everybody agree with that? All right, now that was a specific property. Does anybody remember the property for that?
Symmetric.
That is very good. Symmetric property of congruence. Symmetric property of congruence. Bless you, bless you, bless you. Okay, so number two, if AB is congruent to RS and RS is congruent to WY, then why is AB congruent to WY? That's called the what? Yeah, thank you so much for saying that. Transitive property of congruence. And then why is RS congruent to RX or RS?
Reflexive.
Thank you so much. That is correct. Reflexive property of congruence. All right. Anybody have any issues? Symmetric property. If A equals B, then B equals A. Now, let's see how we're doing on this proof now. Like I say, sometimes I feel like it's easier just to do our own proofs. But let's see. Letter A, PR is congruent to QS. Why is that? That is given. So everybody can write that down. Now let's see who remembers why PR is equal to QS. It looks like these things say the same thing, but they don't. Tell me.
The definition of congruence of segments.
Yes, definition. You can just say definition of congruence. If two things are congruent, their lengths are also what? Equal. Everybody good with that? Now, why does PQ plus QR equal PR? Tell me. You are correct. Segment addition postulate. Very good. Then all of a sudden they use the segment addition postulate again. So what do you think they're going to write there? Tell me, Lexi.
QR plus RS equals QS.
Thank you very much. QR plus RS equals QS. Thank you very much. Now remember, you're trying to say it before we say it and write it down. You're not getting any better if all you're doing is just filling them in as we do it. All right. Thank you.
I don't understand how you get to QS and RS equals QS after that.
You're going to have to help me. I don't understand anything you just said.
Like, you know how you did PQ plus QR equals PR and SAP? How did you get the QS plus RS equals QS?
I didn't have QS. We don't have QS. We have what?
Oh, QR.
That's why. Do you see it now, right? QR plus RS equals QS.
Mr. Stroud,
Oh, I understand.
where is that problem in the ebook? I can't find it.
It's not, buddy. It's on a worksheet.
Oh, okay.
All right. I don't even know if I posted it, to be honest. It's on Classroom. Yeah, oh, that's right. You guys have it. So it's on Classroom. All right.
Do you want me to put it into notability?
Yeah, that's what everybody's doing.
Okay.
All right. So now, Aiden, you good with that?
Yeah.
Now remember, I'm telling you, again, I'm just trying to make it perfectly clear. If all you're doing is just filling this in with me, when you take the test and have to do it on your own, it's going to be a nightmare. All right, you have to try. All right, please try. Now, E. What is the reason for E, Michaela?
Addition property.
Okay, so PQ plus QR and QR plus RS. What are you thinking?
Substitution.
Substitution. Now, for you to be correct, Michaela, you would have to show me where QR is equal to RS. Do we have that anywhere? You see what I'm saying? I like what you were saying. You're just, QR is being added, right? So again, here's where I'm trying to help everybody who's having a little bit of trouble. So Michaela, I need you to tell me if there was PQ equal to QR if there was PQ is equal to RS, I would say you are correct. But does it say that anywhere? No. All right, so now Maren, why is it substitution?
Because PQ plus QR equals PR, and then QR plus RS equals QS.
So PQ right here, this PR right now, again, it's a little unusual, but what does PR equal? PQ plus QR, right? And what does QS equal?
QR plus RS.
Right, that's why it's a substitution. Now, normally I say it's usually the one right before that. Does everybody agree? But does it have to be? No, it doesn't have to be. All right, so that is a good call. That's the substitution. All right, now what's the next step? Tell me, James.
PQ plus QR minus QR equals QR plus RS minus QR.
Yeah, now, again, this is where I think the book is a little inconsistent. Do we have to write that step technically?
No.
No, we can just say what, James?
PQ equals RS.
Yes, PQ equals RS because we just did what to both sides? Subtracted QR. We just subtracted QR. And now because PQR is equal to RS, then we can say what? Yes, we can say PQ, thank you, is congruent to RS. And that's what? That's the definition of congruence. All right. Now, this is a small technicality too, but, I just want you to be, as good as you can. When you put the bar on the top, that's referring to the shape. When you don't put the bar on top, that's referring to the what? Measure. Does everybody agree with that? And again, do I really care if you mix all that up? I promise you I don't care. What I care about is that you're understanding the reasoning behind the proofs. All right, we can fix all the technicalities when we get in more experience. Is everybody okay with that? All right, so I kind of like that. All right, now let's come down here. Actually, I think that's very similar, so I don't care about that. All right, let's do number 2. Let's go to the very end, and then we're going to just go ahead. I kind of looked at these, and I think they're very similar. So I'm going to go ahead and jump to today's lesson, but I am going to do this travel problem. All right. So now we're going to try a proof all by ourselves. All right. Now it says refer to the figure. Deanna knows the distance from Grayson to Apex is the same distance from Reading to Pine Bluff. Prove the distance from Grayson to Reading is equal to the distance from Apex to Pine Bluff. I'll let you start.
GR is congruent to AP.
GR. Why is that?
We have the distance from Grayson to Reading is equal to the distance. Oh, wait, no, it's, is it GA to RP?
Yes,
Okay,
right?
so GA is congruent to RP.
Because that's what it says, right?
Yeah,
From Grayson, from GA is the same as RP. Do you agree with that?
yes.
Or, yeah, all right. So we're going to say that that GA is equal to RP. And let's go ahead and mark it. GA is congruent to RP. Okay, now again, there's lots of things to do. Tell me,
Why wouldn't you put the congruent sign? Why would you do the equal sign?
because they're talking about what?
Right?
Yes. Do you understand me? Do I care if you put congruent by accident? No, I'm trying to convince you when they're talking about a length that's equal, when they're talking about shapes are congruent, the sides. Do you agree with that?
Yes, sir.
All right. So again, if you wrote that, I promise you it's not a problem. Okay. I'm just trying to be technical. All right. So number one, we would say is what? Given. All right. Now, come on, someone speak up. All right. Someone else who hasn't said something today. All right. Tell me about number two. All right, Maren, go.
It would be GA plus, actually,
Come on, just, it can't go. Say what you're going to say.
I was gonna say GA plus AR.
Yes. GA plus AR equals GR. That's brilliant. So that's what?
Segment addition postulate.
Segment addition postulate. All right, now keep in mind, we're trying to prove GR is congruent to AP. That's what we're trying to prove. All right, so now what else can I say? Tell us.
AR plus RP equals AP.
Yeah, I like that. AR plus RP equals AP. And then that's what?
So segment addition postulate.
Now, do I take points off if you write something and you don't use it? No, you can say anything that's true, you can write down. It doesn't affect your grade. All right, it doesn't affect your grade at all. Okay. So now what can I do? Tell me. Hold on, Harrison.
Isn't it like GA plus AR is equal to AR plus RP?
You have to tell me why. What are you substituting?
GR and AP.
GR. All right, Harrison, you got it. Now you got to talk to me because you're almost right, I think. So what on here did you substitute in? You just said, right? You just said this is equal to this, correct?
Yeah.
How? There is a substitution.
Oh,
Tell me, Olivia.
Oh, I was just gonna say, it's the addition property.
What did we add?
AR plus RP equals GA plus AR. I mean, wait, no, yeah, GA plus AR equals AR plus RP.
But then that would equal GR plus AP. If all you're doing is adding this together right here, you would say GA plus AR plus AR plus RP equals GR plus AP. That's what you'd be saying. True?
Sure.
All right, now listen, I'm not trying to discourage you, right? I'm trying to say that's good thinking. All right, but not quite. All right, come on. Good for you, Aiden.
would it be AR plus RP equals GA plus AR?
No. I thought you had it.
Oh,
Tell me.
Mr. Stroh,
AR plus RP equals GR,
AR plus what
RP,
equals?
GR.
Yay, tell me why.
Substitution.
Yay, very good. Sorry, Lucas, I'll get you in here, okay? Speak up loud if you want to. So now I appreciate that very much. So GA is equal to what? RP, right? So he just replaced GA with what? RP. So now step 4 is RP plus AR equals GR. That's definitely a what? That's definitely a substitution. Good job. Now what?
I have a question.
With what?
With the last step, wouldn't that be the same thing as writing GA plus AR equals AR plus RP?
No.
Because GR is equal to GA plus AR.
All I did was I took this GA and I made it RP. That's all I did. I changed GA to RP. This was GA. I changed it to RP. Right? What?
No,
Tell me, come on, Maren, tell me. I'm just
Where did it GA?
the step right above it. GA is equal to RP. Do you see that?
Mhm,
So that means wherever I see GA, I can put what?
mhm,
So here is GA. I replace GA with what?
mhm,
Correct?
mhm.
All right. Now what, Aiden?
Now would you do RP plus AR equals GR plus?
Nope. There's something even easier than that. Tell us, James.
GR equals AP
Why?
because you substitute.
Right. So now what I'm going to do is I'm going to copy this because some of you guys, I'm trying to show you. So that's step number 3. Now what I'm trying to do is I'm trying to show you AR plus RP. What is AR plus RP the same as? What is it?
AR plus GA.
RP plus AR.
Look, I'm highlighting something else now.
AP.
I'm highlighting this right here. Aren't those two exactly the same statement right here? Isn't that the same statement? So I can replace it with what? Right? AP plus AR equals what? AR plus RP equals what? Yeah, but I'm saying this piece, yes, this piece right here, I'm wiping out. Watch me erase. And what am I putting in its place? Why am I putting GR? Yes, the segments are equal, but that's what I'm trying to prove, isn't it? Aren't I trying to prove GR is equal to AP? Right? Now, look, I don't know where you are in this process, but again, it just takes a little bit of what? Practice. I promise you. And I understand it's not easy to see. I am, trust me, I know your pain. I know what you're saying. But if all you're doing, like I said, is just writing it down, it's not meaningful. All right, you're going to see it differently. Can you do this a different way? That's why it's hard for me to grade your tests, because I got to follow your logic. Did we really even use number 3, statement 3? Right, we used it at the end, correct? So it's okay to put it in there, even though we didn't see it right away that we were using that. All right, hopefully that makes sense. All right. So now what I want to do is 2-6. Now, did I put 2-6 in there for you in classroom?
Yeah.
Yeah, the reason I did was because some of you guys had asked me where all the statements are. They're in the book. All I'm doing is copying what? The notes that are in the what? That's all I'm doing. And I posted them here so I could show you. All right. Now, Lucas, are you with me? Sorry, I didn't mean to cut you off. Are you okay?
Yeah, I'm okay.
All right, here we go.
Are we implanting this into Notability too?
Yeah, you can put this in Notability. And Aiden, I'm not sure why those two books are up and open or whatever you're doing, but this is math class. All right. Okay, so now there's a whole bunch of new stuff in this particular section. Now, there was a ruler postulate. Now we're going to call there's a what? Yeah, there's a protractor postulate. I'm not sure really there's anything to that. Other than that, every degree angle from 0 to 180, all right, is on the protractor. All right, I don't think in any single proof we write the protractor postulate. All right, but they're just saying that to me, again, is just common sense. All right. Now, the next one that we use all the time is very similar to the what? Segment addition postulate. This is called the what? Angle addition postulate. So when you add two angles, the two parts equal the what? The whole. That's what some geometry books call it. The parts equal the whole. So in this case, angle ABC plus DBC equals ABC. Yes, no, here, let me say that again, just to make sure. ABD plus DBC equals ABC. That's the angle addition postulate. And again, I remember arguing with my teacher, like, you can't prove that, really? There's no proof to that. All right, we just have to accept that as true. And again, to me, it's common sense. All right, hopefully you agree with that. All right, so that's the angle addition postulate. Now, why are these called theorems? And the other one was called a postulate. What's the difference between a theorem and a postulate? Tell us. Yeah, you can prove a theorem, right? And again, I've said this over and over. We're going to prove a theorem with using what? Postulates. So to me, you didn't really prove it. If you have to write something that can't be proven into your theorem. All right. But again, I didn't make these rules up. All right. So now I need everybody to make sure we know this. If two angles form a linear pair, then they are what? They're supplementary. All right. So as soon as you see a linear pair, you know that those two angles are supplementary. And if they're supplementary, that means they add up to what? 180. That's all that means. All right. So please make sure you're with me. All right. The supplement theorem deals with linear pairs. All right. Two angles that form a line, that forms a linear pair. All right. If they form a linear pair, then they are supplementary. All right. And the same thing with the complement theorem. If the non-common side of the two adjacent angles form a right angle, then the angles are complementary. So these are what's referred to as the non-common sides. This and this are the non-common sides. All right. Again, the complement theorem. All right. If two angles form a right angle, then they add up to 90 degrees. That's not that difficult. All right, here we go for the next one. Now, again, we've kind of already discussed this. Angle 1 is congruent to angle 1 because of the reflexive property. Angle 1 is, if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. That's the symmetric property of congruence. And again, the transitive property holds true also. If angle 1 is congruent to angle 2 and 2 is congruent to angle 3, then 1 is congruent to 3. All right, all those properties hold true. So in the previous section, we did segments, and now we're doing what? Angles. That's it. That's the big difference. All right. Now, just to show you, in my opinion, how silly this is, we are going to, everybody read this with me. The proof of the symmetric property. Here's a mathematician's logic. And again, to me, I just wrote this as what? I used to write on my paper, just common sense. But there is a proof for this. All right, see if you can make sense of the proof. Now, this is kind of like a paragraph proof, which is something we don't do. We could write it in a two statement and reason format, 2-column proof. But listen to this. Given A is congruent to B, prove angle B is congruent to angle A. Yeah, that's what we're proving, the symmetric property. We're proving that. All right, so here's how they prove it. Given that angle A is congruent to angle B, by definition, that means the measure of angle A is equal to the measure of angle B, correct? Now they use the symmetric property of equality, not of congruence, of equality. And if they're using the symmetric property of equality, then the measure of angle B equals the measure of angle A. Does everybody see that? Then, once you have flipped it, you now convert it from equal back to what? Congruent, by the definition of congruence. So anybody else agree that's kind of silly? All right, hopefully you agree with me on that. All right, that's not a big part of geometry. All right. Now, let's look at the next one. All right, the next one talks about congruent supplement theorem. Please watch this one because they use this some. All right. It says angles that are supplementary to the same angle or to congruent angles are congruent. Now, what does that mean? That means if angle 1, now watch me, is supplementary to angle 2, which just means they add up to what? And angle 3 is supplementary to angle what? 2, then what has to be true about 1 and 3? They are congruent. All right, they are congruent. Now, again, to me, that was kind of obvious. Now, sometimes it's not as obvious because, it's hard to visualize. So what I do is I said, okay, let's say angle 1 is 140 degrees, then what would angle 2 be? 40. And if angle 2 is 40 and it's supplementary to angle 3, then angle 3 would have to be what? And so what's true about angle 1 and angle 3? Yeah. Does everybody see that? So sometimes visually it's not hard to see what I'm saying. But if you say 1 and 2 are supplementary and 2 and 3 are supplementary, then 1 has to be congruent to 3. So if angles are supplementary to the same angle, or if angles are congruent to the same angle, then they are congruent. All right, hopefully that makes sense. All right, and then the same thing for what? Same exact thing for complements. Right? If 2 angles are complementary to the same angle, then those 2 angles must be what? Congruent. Anybody have any issues with that? All right, and we'll prove that, I'm sure. All right, now something we knew in 6th grade. Vertical angles are always what? Vertical angles are always what? Help me. Congruent. That means 1 and 3 are congruent. And that means what? 2 and 4 are congruent. And we can easily prove that now. Easily. All right, and we will be doing that. And now here's some right angle theorems. Let's see if this makes sense. Now, again, I'm hoping every one of these is common sense. Perpendicular lines intersect to form 4 right angles. Right? That's the whole definition of what? Perpendicular. They form right angles. All right. So perpendicular lines always intersect to form 4 right angles. Now, this sounds kind of silly, and we're going to prove this, maybe. All right angles are what? Congruent, because a right angle measures how many degrees? And all 90 degrees are equal, right? And all right angles, or all 90 degrees are right angles. All right, I thought that was kind of obvious. Now here, 2.11, perpendicular lines form congruent adjacent angles. Why are they congruent? Because they're right angles. Why are you telling me this? That's obviously true. Is everybody good with this? All right. 2.12. If 2 angles are congruent and supplementary. If they are congruent and supplementary, everybody knows that, they would have to both equal what? 9 degrees. We definitely can prove that one. Is everybody okay with that? And last, stating the obvious. If 2 congruent angles form a linear pair, then they are what? Right angles. If 2 congruent angles form a linear pair, then they are right angles. I just think every single one of those is just makes perfectly good sense. And I don't think I needed to tell you that. I think if I wrote those down, you'd all say, yes, those are true. All right, anybody have any issues? All right. So let us begin. Let us begin here real quick. All right. Now it says, find the measure of each numbered angle and name the theorems that justify your work. So if I said measure of angle 2 is 26. So here we go. I'm going to come over here and put 26 degrees. Then what can we say about angle 3? 64 degrees. And then angle 1 is what? 90. Okay. I don't care about naming all those things. All right. I just want to make sure you can do it. All right. So that's number 1. All right. Now we're looking at number 2. All right. Now here's where some people made some mistakes. Those were the numbers for number 1, correct? Now we're going on to number 2. So here they're saying the measure of angle 2 is x, and the measure of angle 3 is x minus 16.
X plus x minus 16.
Yeah, so listen, I don't want to waste time doing the math on that. I just want everybody to be able to tell me x plus x minus 16 equals what? Equals 90. Don't do the math on that. There's much more difficult things we need to get to. All right. So now what's true about question number 3? What equation am I writing? Tell me, Maren.
3x plus 9 equals 180.
Yes, perfect. 3x plus 9 equals 180. Don't worry about solving that. I know everybody here can solve that. And someone else. Nate, tell me about number 4.
4x plus 6 equals
Come on. Equals what?
180.
Yes, but I'm not sure how you got the 6.
Oh, no, it's not 6.
What is it?
It's 4.
Yes, thank you. All right, so he did a little work in his head, but I'm okay if you just wrote 3 parentheses x minus 1 plus x plus 7 equals 180. Don't solve that. I just want to make sure. Okay. All right, now what I want to do is, I want to see if I did number 5. What I did is I tried to write the proofs down for you, so to save us some time. Or does everybody see what I did? All right, I wrote out the statement and reason for you. Is everybody good with that? All right, so what we want to do is, let's just look at this parking lot for a quick second. All right, we're not going to do the proof for number 5. We're just going to try to read through it. So we know that 2 is congruent to 6. So let's highlight 2. And let's highlight 6. Those are congruent. And then it says 4 is congruent to 8. Oh, that's what we're trying to prove. That's what we're trying to prove. Can somebody just in words kind of try to tell me how I know that's true?
Well, 2.
Tell me, okay, Lucas, let me speak up now.
2 and 4 are supplementary, and 6 and 8 are supplementary, and 2 and 6 are congruent. So 4 and 8 have to be congruent too.
Lucas, that was, of course, super great. That was really good. Now, the problem I'm having is, I'm going to turn up my volume here. I don't know why you're not coming through very good. You're just coming through my computer. All right. So everyone take a look at what he said and make sure you can see that. All right. I don't think that was as obvious. All right, Lucas, say it one more time, a little louder. I'm going to blow this up.
2 is supplementary to 4, and
2 is
6
supplementary to 4.
and
Go
6
ahead.
is supplementary to 8.
6 is supplementary to 8.
And 2 and 6 are congruent.
And 2 and 6 are congruent.
So 4 and 8 have to be congruent.
4 and 8 have to be congruent. And that's kind of that supplement theorem. All right. Is everybody okay with that? Anybody? Now look, I'm trying to tell you, if you're sitting there going, man, I'm just not seeing that, I'm totally understanding. All right, I don't mind drawing it out for you. Anybody want me to say anything more about that one? 2 and 6 are equal. And they're supplementary. So their supplements have to be what? Their supplements have to be equal. I feel that's pretty good. All right, now let's go down to the next one. All right, the next proof is important. All right, as we go down the page. All right, I think we're making some progress. All right, let's see. Copy and complete the proof. Angle 1 and 3 are complementary, and 2 and 3 are complementary. So this is the theorem, correct? We're trying to prove that 1 is congruent to 2. Does everybody agree with that? All right. So we're not just saying because they're complementary and they're congruent, they're equal. That's not what we're saying. All right. We're trying to prove that theorem. All right. Does everybody understand what I'm saying, right? We're completing the proof of theorem 2.7. All right. So here we go. Angle 1 and 3 are complementary, 2 and 3 are complementary. What is that? Given. Measure of angle 1 plus the measure of angle 3 equals 90. Measure of 2 plus measure of angle 3 equals 90. What is that probably? Say it. You know what? Almost. But what does complementary mean? Adds up to 90. So what could we call that?
The addition number.
No. So what is it?
The congruent.
No. That's what we're trying to prove. That's what we're trying to prove. So everyone, I'm totally understanding this. It's just what? Definition of complementary. When something is complementary, that means they add up to what? 90 degrees. That is the definition of complementary. The definition of supplementary is what? Two angles that add up to what? 180. Is everybody okay with that?
Why would it be the congruent complement theorem?
Very good question. Did you read the question itself? It says copy and complete the proof. Yeah. So listen, on the test, right, I had made a mistake once of not writing, we're trying to prove this theorem. You can't use the theorem to prove the theorem, right? So everybody needs to understand what Lexi just said again. Everybody hearing me? I'm going to talk like this. And if you're just like letting it go over your head, you're not understanding. We know this is true. Does everybody agree? We know it's true. But what we're trying to do now is we're trying to write the proof so we don't have to do this every single time. We can apply the theorem once we know it's true. That's all we're doing. Are we going to prove all the theorems? I don't have time to do that. Can I prove all the theorems? Yes. Not just me, but what? You can prove all the theorems. We're just not going to do that. All right. So now hopefully you understand. All right. So now letter C, what is that? Say it again. Substitution, right? Measure of angle 1 plus measure of angle 3 is 90. They're both equal to 90, so they're equal to each other. I like that. Substitute, what?
Why wouldn't it be addition?
What are we adding?
The equals.
Both of these are equal to 90, right? So now watch what I'm going to show you. Do you see what I'm saying? Because this is that us? All right, hold up. No, don't go anywhere. Don't slam real quick. So I want everyone to try to finish up this proof. I want you to try proof number 7 and then 8, 9, and 10. And I'll work with you tomorrow, the proofs on 14, 15, 16, and the rest of it. Man, time flies when you're having fun.
It's just all for 8, 9, and 10. Do you have proof?
No. Just tell me the answer. Right. All right. Thank you, Lucas.
Bye.